Hi everyone, I am Jack and welcome back to my channel. I hope you are doing well. This is day 2 of our 30 days C programming challenge. Today's topic is structure of a C program and compilation process. So without any delay, let's dive right in. Here I am going to tell you the structure of a C program and then explain it for you by parallelly typing the code. So coming to the structure of a C program. C program structure was mainly divided into different sections like documentation section, pre-processing or linking section, definition section, fourth we have global declaration section, fifth we have main function, and sixth we have subprogram section. And this main function has divided into declaration part and execution part. Right. Now I'm going to show you the structure and explain it to you by the writing code parallelly. So coming to the code. So this is day 1 we have created yesterday. Let's create another folder, that is day 2, and create a C file. I'm naming it as main.c. You can name it anything. So coming to the declaration. So here declaration is used to provide the information about the program, such as its purpose, author, date of creation, or any important note, but it's optional. So like if I am going to write a code that is addition of two numbers, so I can write it as the title is addition of numbers, right? And then I can write date of creation, that is 22nd August 2025, and author as Jack, and note as channel. So this is the documentation session where we write anything about the code, but if you write like this it throws us error. This is why we need to use comments. Comments are nothing but the line of code or text that is not a part of compilation. The compiler won't touch it while compiling and executing. So there are two types of comments. One is single line comment, another is multi-line comment. So we write single line comment like this. In front of the text, we use double slashes. Double slashes means it's a comment. So the compiler won't touch it and won't execute it and won't even throw the error if you write anything in it. Right. And if you want to use multi-line comment, you can use like slash and then asterisk and then enter. So this is the multi-line comment. If you write this inside it, those are all we get inside the comment. So this is the multi-line comment and this is a single line comment. And all of this we call it as documentation. So this is the documentation that tells about the program. And coming to the pre-processing or linking section, we all know that the program start with hash include .h, right? So here in this section, it includes preprocessor derivatives like hash include, which links necessary header files like stdio.h for input output operations. Okay, this is called preprocessor linking section. And coming to the definition section, here in this section, we use hash define derivatives to define constants like hash define pi space 3.14159 like that. It means this defines a constant value pi, that is pi value 3.14, a constant value. So it should be declared after the header file. It's called as definition section, right? So we are defining something constant value here. And coming to the global declaration section, here we define the variables or functions, function prototypes like int max is equals to 100. So this is the global declaration. So this is a variable and I have given a value of 100. So this variable will take this value throughout the program. This is called global declaration. And we can also declare the prototype of a function like this. So this is the prototype of a function called as sum. So that we use in the later part of the code. And coming to the main function, so this is the main function. Brackets that shows the limits of the main function from here to here. So inside it we should write the execution part. So in the main function we have two like declaration part. So we can declare any variables like int a is equals to 10 or b is equals to 5 like that. This is called declaration. And execution part, like we can write anything like printf statements hello C, or we can write anything like this to call a function like sum of a comma b. So don't worry, I will tell you all of this in the upcoming videos. You just see the structure of the program. So this is the execution part, and we can write anything logic, any logic in it. And at last, in the main function, we use return 0. So this will return 0 because it says that the program has been successfully executed to the operating system. 0 means success. And at last, we have subprogram section. So main function has been completed. Now it's about subprogram section. So subprogram is written outside the main function. So it can be anything, like it also known as user defined function. So user will declare his own function. Like if I am going to declare a function like int sum is the name of the function, and int a comma b, sorry, int b, int c is equals to a plus b. So I'm performing the addition operation and returning the result. Okay, this is the subprogram section. So this is all about the structure of a C program, how it look like. So you can check it by running the code. So after running the code, we will get that it prints a hello world because there is a printf statement, and another one, it prints the sum of the two numbers, that is 10 and 5, like this. So whether it works or not, we'll check it by running the code. Yes, it's shown. And another one is, forgot to tell you that we can use a backslash n at the end of the print statement. Backslash n is nothing but it creates a new line after the end of that text, that is hello C. So if I run it now, after hello C has been printed, then the sum will be printed next to the next line to the hello C. So run it. So you can see that this is the printf statement hello C, and this is the executed part, that is sum of two numbers 10 and 5, that is 15. Sum of a and b 10 plus 5, that is 15. So it's working. So this is all about the structure of a C program, from documentation to the subprogram section. I hope you understood the structure. Now it's time to see the compilation process. So actually, we want to see the output of this program. We just click the run button, as it is performing the compile and run at a time. But in general, the program first undergoes the compilation of the code and creates a executable file, and the executable file will show us the output. So let us see how it works. So open your terminal. So we can open terminal by clicking here. So as we are in the C playlist directory, so we need to come to day2 directory. So we need to change the directory by typing the command like change directory cd space day2. So we have came inside the day2. So clear the terminal. So we are in the day2. Now we need to compile and run the program manually as gcc space main.c space -o space main.exe. So what does this command means? Here the GCC means GNU compiler collection, the compiler that converts your C code into machine code, right? And main.c is nothing but your source file that contains your C code. And here the -o represents that output option. It tells the compiler to save the compiled result with the given name, that is main. Okay. So it tells that you need to convert the file from this one to this one. Okay. And main.exe is the executable file that is created after compilation. Okay. So if I click enter and run the command, so you see that the code has been compiled successfully and a executable file has been created. Now the operating system will execute this executable file, that is main.exe, by running the command as main.exe. So if I run it, we will get the output. So we got the output, right? hello.c and 15. So this is the process that first it compiles and creates a executable file, and then after executing this executable file we get the output. So this is the process we know that our college taught us. But what actually happens at behind the scene of compilation, that I am going to show you with a live proof. Okay, get ready for it. So I'm going to delete this file and killing the terminal. Coming to the compilation process, we actually know that the C file undergoes two steps. That is, first one is compilation and the second one is running. It's nothing but execution. But what actually happens is, in this process it takes four main steps, which includes pre-processing, compiling, assembly, and linking, right? So the C source file will undergoes these four steps and gives us the executable file, and this executable file run and gives us the final output. The preprocessor handles the derivatives like hash include has defined, and it includes the content of the header file into the source file and removes the comments. After preprocessing, we get a single file with .i extension. The compiler takes the preprocessed code and translates it into assembly language, and it performs system checking and semantic analysis and report any errors or warnings. So the output is an assembly file with an .s extension, right? Coming to the assembler converts the assembly language code into machine code, that is binary instruction. This machine code is stored in the object file with .o extension or .obj extension in Windows, right? In linking part, the linker combines one or more objects files with necessary library files. It creates a single and complete executable file that can be executed by the operating system. This file has no extension on the Linux or Mac, but .exe in Windows. So let us see this practically. So here is the code and I have deleted the executable file. So open your terminal and come to the main page, that is day 2, and clear the terminal. So we are in the day 2. Now we need to create single file, that is with .i extension. So to create it, we need to write the command as gcc space minus capital E. So minus E will prevent it from compilation. It does only up to the preprocessor. Okay. So gcc space minus I space main.c to main.i. Okay. So it converting from main.c to main.i. This is the first step in the actual compilation. So we got a main.i file that includes all the header files, has defined and all. So you can check here. So no one has shown you this, right? And it includes all the path and where it should take from, right? So like this. So it going from main GW include and stdio.h. So it including the .h file in this way. So this is the first phase in the compilation process. This .i extension file will be converted into assembly file by giving the command as gcc space minus s space. So minus s tells stop after compilation and gives the assembly code. So we know that the second stage is compilation. So the minus s will prevent it from going beyond the compilation. It stops up to the compilation and gives only the assembly file. So it won't gives us the executable file. So that's why we need to include minus capital S. And then we are converting from main.i to main.s. This is the assembly file which has the extension as .s. Yes, we have got an assembly file. So this is the assembly file. It looks like this. So this will check all the necessary syntax and semantic and give it has like this. So you can see as dot ASCII hello C and all and percentage D like this. This is the second stage of our compilation process. And the next one, the assembly file will be converted into the object file. So for this, type gcc space minus c space main.s from assembly file to object file main.o. If you run this, so we have got an main.o. So you can see that zeros and ones inside it, but it's not displayed because it's encrypted. It is in the binary instructions, so human cannot read it. We cannot read it. Okay, machine can read it. So if you want try to open this, we will get an encrypted text like this. So we cannot understand this. This is the object file. So this is the third phase of compilation. And if we need to go further and get the executable file from the object file, gcc space main.o from object file to executable file. So at last we will get the executable file. So you can see that executable file. So after going through all these steps, at last we have got the executable file. But previously, while we are compiling, it directly coming from C main source file to the executable file. But here I have created different files that are in between of C file and executable file. Okay, this is the proof that our compilation process undergoes in 4 different phases. And at last, if we want to execute that executable file, the command is main.exe. So we can include it .exe or we cannot include it's not a problem. So if I run main, we will get the output. In this way, the compilation process will be done in the machine. I hope you understood the concept behind compilation process. Okay. Today we have discussed the structure of a C program and the full compilation process. Tomorrow I am going to discuss about the data types and variables. So let's meet in the next video. Till then, take care and keep coding. This is Captain Jack signing off.